show you the second major tool that's called a GEBV calculator. Okay, GEBV calculator will use your calculated blue blob and also your marker matrix, bring these together, give you another factor to estimate your breeding value. That's why genomic estimated breeding value. It's not only based on your phenotype. So the model we have here is a two-step approach to use your calculated phenotype, not just the simple mean, even though in this scenario it's the same as the blue. But looking at your response rate, once you choose GEBV calculator, so if it's already in the galaxy, then you open the GEBV. So find the GEBV prediction from here. So the first input file you want to use is called a phenotype. Okay, choose this already directly give it option. So the one is called a phenotype GEBV 10-fold cross-validation demo file. Is everyone good? If you are not, raise your hand. Okay, so in this file, there's a drop-down menu for you to choose the parameters. So the header containing the sample name. So that's the sample name that's in column 1. Okay. Next column containing the first phenotype is column 3, the GY blue. That basically is the output from the previous two. Okay. And then the last column here, I only want to analyze one phenotype at a time. So my first column, my last column, I will choose the same thing. If you want to analyze several traits at the same time, you may have yield, you may have plant height, you may have disease, etc. You can choose multiple. But baby step, everyone just choose one phenotype. This phenotype is my blue, because in my GEBV, I use the estimated yield.
Technical answer. The basic thing is that because you shrink blups, they're not really on the natural scale exactly anymore. Blues are not shrunken, so they're, if you measure your trait in kilograms per hectare, blues are still all in kilograms per hectare. Whereas the blups, different individuals have different amounts of information, so they'll be differentially shrunken. I mean, you would still express a blup in kilograms per hectare, but then you're going to run a prediction equation. The prediction equation is also a random effect, and so it's going to shrink things again. Basically, you don't want to do double shrinkage, which is what you would have.
Already, I don't know what you think, Jean-Luc, if that's a useful feature or maybe
you want to these are details. It'll still work if, I mean, you know, don't get bogged down by the fact that we don't have a de-regress tool up yet. I mean, go ahead and use the tools to do the analysis.
Yeah, we have a tool. We could wrap that if that's really important for you. Okay. So anyone already have the current parameters selected? Okay, so the sample name selected, and then your Y is the blue, and the last column, the Y is also blue. Then the response type is Gaussian. So basically there are two options. One is a Gaussian, one is an ordinal. So the Gaussian basically just like a continuous distribution, ordinal more like categorical data. So mostly what we do the GEBV is Gaussian type of data. And many parameters here, if you're a breeder like me, you just leave as a default, okay? Do not have to choose anything. So the only thing here is incidence matrix and the model, okay? So incidence matrix here is for you to pull your genotype matrix, okay? So the incidence matrix here, we have two options. So one is called untransposed genotype, another one called transposed genotype. This part is pretty important. You will run into error if you're not paying attention here. So the flapjack file, the output file from GOBii, or when you receive flapjack type of, means if you have the marker on top and you have the sample on the left, that's the orientation. So this kind of orientation will match exactly with your phenotype, okay? Because your phenotype have the sample name on the left, and you have multiple column traits on top. This one match phenotype, right? If your markers on top, you have the samples on the left. This one is called IRRI transposed. If you have your samples on top and you have markers on the left, this is called untransposed, okay? So you will need a transposition tool here. So you look at your file. So the genotype file, for example, you click on the transpose, view the data. So I give you two options for both transpose and transpose. Here, a little bit slow. So if you view your data, transpose, you can see I have this RS number. So if you're familiar with HiveMap, RS means marker name, okay? So my markers on top, that means my samples on the left, okay? This one is already transposed. So it's very important you know these two currently the orientation requirement. If it's already transposed, the BGRR in the backend assume your genotype, your phenotype already sorted based on your samples, exact order, exact sequence, and then your genotype file. You do not need the header for the sample name, but you need a header in the marker name. That's your incidence matrix, all right? So here you do not need to choose, need a transposition if that file you upload here called already transposed. If you do have the genotype file like a GOBii HiveMap, GOBii HiveMap come in with the samples on top, the markers on the left. So this orientation will be different, exact opposite from your sample, the one from GEBV testing, right? With samples on the left and your phenotype on top. So you will have the marker matrix, you need a transposition, okay? So that the samples need to be sorted in the same sequence. So let's take a look at the untransposed file. This is the GBS sample name layer on top. You can open that up as an Excel file if you want. That's where you load it. Before you upload it, you already need to know so what kind of orientation this. So basically, this file is your marker from the left. You remove that the first column, but your sample is on top. And this tool, if you choose untransposed file here, okay, so this marker matrix, I will choose this untransposed, okay, and then you choose a model. Currently, we have the Bayesian rigid regression, Bayes A, B, C, and Bayesian lasso. These are 5 different models. You can run one at a time and then compare your model to see if you get a better correlation between your predicted and observed. And then from here, do you need a transposition? Because my genotype is in opposite direction. I have the samples listed as my header on top, right? So my markers. So you need that transposition. So I click on yes. Okay. If you choose the other one I showed you, then you click on no. Either will be fine. Okay. But this step is very important when you use your own data to do the analysis. You need to look at what's in my default file to modify your own test data so that you can run with these tools. So these are parameters you can keep as it is. If you want to know more, there's a reference for BGRR. For the time's sake, I'm going to leave as it is, okay? All the rest you can leave as it is. And then for the cross-validation, you can choose k-fold cross-validation. You can leave as without validation. So the number of folds you can choose. So here as default is just 5 folds. You need to choose k-fold. Your output should show you the correlation. Okay, that means between your observed and your predicted. That's your output. If you didn't choose that, then you will see two columns after the sample name. You will have the observe, you have predict. So in order for you to compare your different model, you want to run this cross-validation to see which model is better. You get only one output file when you run cross-validation. The purpose here is for you to select your models. Okay, so I chose the ridge regression. After that, you can go back to choose other 4 models and then see your correlation. From here, you can look at it. So basically, that's your randomization 1 to 10, and then you have the blue correlation. So it's about 0.1 to 0.2 is when you run RR blob. And then if you want to say, how about other models? You click on this job, and then you click on run this job again. You will have to refresh. You run this again. And keep all the parameters as it is. The only difference is you choose a different model this time, okay? So you can choose any of the other 4 models. For example, this morning Jerome presented the base B may be better, so I choose base B and see how that works. Keep everything as it is, then execute. This is the model selection step. And then if you want to run this for the other 3 models, that's okay. If not, we can rerun, remove the cross-validation, only do the GEBV calculation. Basically, that's only one run instead of 10. So you're not looking at the file folds. Everyone, okay. So this one is base B. So this base B seems lower number, right, of the correlation than the other ridge regression. Right, the other one, the data is here. So you can look at the top and the bottom. Yeah, these two overall, which one give you higher correlation. So this is the part of it. So you want to compile your outputs in some kind of visualization tool. Okay. So let's say if one model is significantly better than the other, normally they are not. Then you say, okay, I will start using this model for this type of data. So here I want to say rerun without cross-validation, but because I want to see the GBE value. So I chose no cross-validation and just execute. And this way you will receive the observed and you will receive the predicted in 2 columns after the sample column. So looking at the output, so you see, right, the first column is your sample names. Second column is your blue observed. That's the original input file, basically. And then your predicted is in the last column. You can look at the data. So basically, this just gives you another phenotype data if you want to do the advancement based on looking at your GEBV, okay, for your list of germplasm. All right, any questions? So basically, this is our workflow 1. Workflow 1, you do your blue blob, and then you do GEBV. Your input file is already pretty well, very clear, okay?